కొంచెం 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 లేదు మధ్య కొంచెం ఇంకొంచెం ఇంకా 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 చాలా డన్ రైట్ ఇస్తారు ఇంకా 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 ఓకే సార్ డన్ కిందికి కొంచెం పైకి ఓకే సార్ ఓకే సార్ పైకి ఓకే ఇది కూడా ఇంకా కిందికి ఇంకా 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 ఓకే రైట్ రెడీ రాయ్ రెడీ రెడీ కంప్లీట్ ఇది పాస్వర్డ్ తెలుసా అన్న ఈ పాస్వర్డ్ చెప్తుందా ఇది పోయింది కదా ఐడి ఆన్లైన్ శివాని పాస్వర్డ్ గట్రా లేకుండా చూసుకో పాస్వర్డ్ 748
వస్తున్నా ఈ యాప్ దగ్గర ఉన్నా వస్తున్నా 10 నిమిషాలు యాప్ దగ్గర ఉన్నా యాప్ అతని దగ్గర వస్తున్నా అనే ఇచ్చిండు డిజైన్ ఇచ్చిండు తీసుకొస్తాను. హలో సార్ వస్తాను సార్ ఇక్కడే ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం సార్. ఓకే సార్ ఓకే వస్తాను సార్ ఇక్కడే ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం సార్. ఓకే ఓకే సార్ ఓకే సార్ ఓకే వస్తాను సార్ ఇక్కడే ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం సార్. ఓకే ఓకే సార్ ఓకే సార్ ఓకే వస్తాను సార్ ఇక్కడే ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం. ఓకే ఓకే సార్ ఓకే సార్ ఓకే ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం. ఓకే ఓకే సార్ ఓకే సార్ అది కట్ చేయకపోయినా ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం. ఓకే ఓకే సార్ ఓకే సార్ అది కట్ చేయకపోయినా ఉన్నాం బిల్డింగ్ కాడనే వస్తున్నాం. ఓకే ఓకే సార్ ఓకే సార్ గుడ్ మార్నింగ్. బిల్డింగ్ కాడనే వస్తున్నాం. In the last class we are discussed about different type of hybridations and types of hybridations are discussed. In that the hybridation means valency orbitals are overlapping with each other. Valency orbitals are overlapping with each other to form different hybrid orbitals. Valency orbital means generally one s orbital is present, 3 p orbitals are present. Okay. 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 Okay sir. Good evening. In the last class, we are discussed about hybridization and different types of hybridization we are discussed in the last class. What is the hybridization? The hybridization means the valency shell orbitals are overlapping with each other. Valency shell orbitals are overlapping with each other to form different hybrid orbitals. So, why hybridization takes place? When two or more number of atoms are combined, the hybridization concept is involved. So, due to this hybridization, first of all, the molecules will attain equal energy level and it gets the stability. What is meant by stability? The stability means in the valency shell either 2 electrons, equal energy 8 electrons, 18 electrons or 32 electrons are present, it is called stability. If 2 electrons are present, it is called as duplet configuration. If 8 electrons are present, it is called octet configuration. If 18 electrons are present, it is called pseudo-octet configuration, and 32 electrons. Based on that thing, what about the stability takes place? If valency shell, one s orbital and 3 p orbitals are overlapping with each other to form sp3 hybrid orbitals. Now, in sp3 hybridization, one s orbital, 3 p orbitals are combining means total 4. One s orbital, 3 p orbitals are combining, that is known as sp3 hybridization. Total number of hybrid orbitals is 4. Means it form, there is generally S structure is spherical structure, P structure is dumbbell structure. When S and P combine together to form new hybrid structure, that is sp3. In case of one s orbital, 2 p orbitals are overlapping with each other, that is known as sp2 hybridization. Number of hybrid orbitals is equal to number of sigma bonds. Number of hybrid orbitals is equal to number of sigma bonds. Number of unhybrid orbitals is equal to number of pi bonds. Sigma bonds are formed by linear overlapping, like this linear overlapping sigma bond is formed, lateral overlapping pi bond will be formed. Sigma bond linear overlapping, due to that orbitals are merged together, the bond strength is more. Comparatively sigma bond and pi bond, the sigma bond strength is more comparatively pi bond. If valency shell, one s orbital and one p orbital is combined together, that is known as sp hybridization. So, if sp hybridization, how many orbitals are combined? 2. One s orbital, one p orbital, that is 2 sigma bonds are formed. In sp2 hybridization, one s orbital, 2 p orbitals, total 3 sigma bonds. In sp3 hybridization, one s orbital, 3 p orbitals, total 4. And sp3d hybridization, one s orbital, 3 p orbital, 1 d orbital, total 5. And sp3d2 hybridization, one s orbital, 3 p orbitals, 2 d orbital, 1 plus 3 4, 4 plus 2 6. Whereas and last one is sp3d3 hybridization, that one is 7. So, number of hybrid orbitals is equal to number of sigma bond. If any molecule having 2 sigma bonds, it belongs to, what about this hybridization? Based on the hybridization, we can express this condition. If formation of sp3 hybridization, in case of formation of sp3 hybridization, the definition is sp3 hybridization means valency shell, one s orbital, 3 p orbitals are overlapping with each other to form 4 new sp3 hybrid orbital. 4 new sp3, how it will be 4? One s orbital, 3. The best example for the formation of sp3 hybridization is methane molecule. The formula of methane is CH4. Coming to that, carbon atomic number is 6. Electron configuration 1s2, 2s2, 2p2. This one is first shell and this one is second shell. In the second shell, total number of electrons are 4 electrons are present. In that 4 electrons, here s orbital is 2 electrons, whereas p orbital is also 2 electrons are present. This one is ground state electron configuration. This one is ground state electron configuration. Now, according to the Hund subrule, half filled configuration or completely filled configurations are more stable. So, here how many unpaired electrons are present? 2 unpaired electrons. If the valency shell, the same shell it will be there, this valence shell electron is excited and enters into the p orbital. So, now it is converted to here s orbital 1 electron and p orbital here 3 electrons are present, 3 unpaired electrons. This is belongs to excited state electron configuration. This is belongs to excited state. Why this electron is excited? Because of two conditions. According to Hund subrule, half filled configuration and completely filled configurations are more stable. When this electron is excited, in the outermost shell, half filled configuration is there. Outermost shell, half filled configuration is there. Due to this reason, this compound is more stabilized. When how many unpaired electrons are there here? The total number of unpaired electrons are 4 electrons are there. To form the bond, and bond consisting of 2 electrons. One bond means one line how many ends are present? 2 ends. If you take any bond, the bond we can representing like this. Is how many ends are present? Here 2 ends. 2 ends means it is designated as 2 electrons. Now, here how many unpaired electrons are there? 4 unpaired electrons. 4 2s are 8. So, 8 means in the valence shell 8 electrons, octet configuration is stable. Now, coming to here, methane molecule is belongs to sp3 hybridization, one s orbital, 3 p orbital is overlapping with each other to form sp3 hybrid molecule, and this carbon outermost electron configuration is like this. At the same time, if we take hydrogen atomic number 1, electron configuration is 1s1. Hydrogen atomic number 1, electron configuration is 1s1. We see here, this is hydrogen, that atomic number 1, electron configuration is 1s1. And if you see that the electron is excited in the, what about this outermost shell, half filled configuration is there. Here 4 unpaired electrons are present. It is undergo the sp3 hybridization to attain equal energy level. Now, s orbital structure is spherical structure, p orbital structure is dumbbell structure. When s and p is combined together, the new hybrid structure is obtained. The new hybrid structure is tetrahedral geometry. The sp3 hybrid molecule structure is like this. It is a tetrahedral geometry. It will be takes place. The central atom is carbon. Here the central atom is carbon. This is the central atom. The central atom is carbon. Here one s orbital, 3 p orbitals are overlapped here. These all orbitals are sp3 hybrid orbitals, and every orbital 1 electron is present. Here also 1 electron, 1 electron, 1 electron, 1. The central atom is carbon. These all orbitals are sp3 hybrid orbitals. These all orbitals are sp3 hybrid orbitals. Plus hydrogen. The electron, hydrogen electron present in the s orbital. S orbital structure is spherical structure. S orbital structure is spherical structure. This is the nucleus. In the center of the nucleus, here 1 electron is present. Hydrogen valence shell, first shell is present. In that 1 electron is there. This one is nucleus. And this atom is hydrogen atom of 1s. How many hydrogens, how many terminals are there here? 4. We have to take 4 hydrogens. These 4 hydrogens are bonded in the 4 corners of the central atom of carbon. The structure is here, and here 1 hydrogen is present. Here also 1 hydrogen. Here also 1 hydrogen. This one is carbon electron and this one is hydrogen electron. One is carbon electron, another one is hydrogen. One is carbon electron, hydrogen. Like this, carbon and hydrogen. Now the central atom is carbon. This orbital is sp3 hybrid orbital. This overlapping is s. sp3 s overlapping. sp3 s overlapping molecule. Now the structure is what type of structure? It looks like tetrahedral. This is the orbital representation of the molecule. If you are taking in the bond structure, here carbon, Here one hydrogen is present, here also one hydrogen. These are the bonded electrons. Carbon surrounding total 4 electrons, 4 to the 8, whereas hydrogen surrounding is also 2 electrons are there. So, the molecule is belongs to tetrahedral molecule. The molecule is belongs to what type of molecule is a tetrahedral molecule. Its bond angle is 109 degrees 28 minutes and overlapping of orbitals are sp3s overlapping and structure is tetrahedral structure. And the bond length means carbon to hydrogen, the bond length is 1.11 angstroms, it will be takes place. So, this is the formation of methane molecule according to sp3 hybridization. In case of sp2 hybridization, valency shell 1 s orbital and valency shell 2 p orbitals are overlapping with each other to form sp2 hybridized molecule. Valency shell 1 s orbital and 2 p orbitals are overlapping with each other to form 3 new sp2. Why 3 new? Because of 1 s orbital and 2 p orbital, 1 plus 2 total 3 new sp2 hybrid orbitals are formed. And this is unhybridized orbital. Generally unhybridized orbitals are forms pi bonds, hybrid orbitals are forms sigma bond. Number of hybrid orbitals is equal to number of sigma bonds, number of unhybrid orbitals is equal to number of pi bond. Coming to here formation of boron trifluoride molecule, BF3 molecule. According to this, here boron atomic number is 5, electron configuration 1s2, 2s2, 2p1. Here valence shell total number of electrons are 3. When valency shell total number of electrons are 3, it belongs to third group of element. And here s orbital 2 electrons are present, and whereas p orbital here 1 electron is present. This one is ground state electron configuration. Now see here, in that valency shell total number of electrons are 3, but according to the ground state system here only one unpaired electron is there. But in the formation of boron trifluoride, how many number of fluorines are there? 3 fluorines are there. Means 3 fluorine, every fluorine atom. Here fluorine atomic number 9, electron configuration 1s2, 2s2, 2p5, s orbital 2 electrons, p orbital is 5 electrons, 1, 2, 3, 4 and 5. In every fluorine atom, how many number of unpaired electrons? 1 unpaired electron is present. So, 1 unpaired electron means it forms only 1 bond. If 2 unpaired electrons are there, 2 bonds, 3 unpaired, 3. Number of unpaired electrons is its valency also, we can say that. So, here fluorine valence shell total 7 electrons are there, it belongs to 7th group of element, and in the fluorine valence shell how many pairs are present means total 3 pairs are there. In the fluorine valence shell total 3 pairs are present and 1 unpaired electron is there. So, this 1 unpaired electron participation in the bond participation it will be takes place, it forms sigma bond. Now, here in the boron valence shell only 1 unpaired electron is there. So, if you are adding some amount of energy, this s orbital electron enters into the p orbital. Why s orbital electron enters into the p orbital? To get the stabilization. Here only 1 bond is formed. If electron is excited, because of here empty orbitals are there. If more number of unpaired electrons are there, more bonds. More bonds means outermost orbital stability is increases. So, that is the reason here this s orbital electron enters into the p orbital. When s orbital enter electrons in the p orbital, in the valence shell total how many unpaired electrons are there? 3 unpaired electrons are there. So, this is belongs to excited state electron configuration. This is belongs to excited state electron configuration. Now coming to that, here why hybridization is takes place? Because of one electron is present in the s orbital, two electrons present in the p orbital. S orbital energy, p orbital energy is different. S orbital is ground state, p orbital is excited, and after that d orbital, and after that f orbital. Like this, energy gaps are there. So, but here the unpaired electron is present in the p orbital. The unpaired electron, fluorine unpaired electron present in the p orbital, but here the unpaired electrons present in the one electron is in s orbital, two electrons in p orbital, means it is a different energy level it will be takes place. To attain equal energy level, hybridization is takes place. So, valence shell one s orbital, two p orbitals are overlapping with each other to form sp2 hybrid molecule. To form sp2 hybrid molecule. Due to the formation of this sp2 hybridization, number of hybrid orbital equal number of sigma bond. So, now s orbital structure is spherical, p orbital structure is dumbbell, but when s and p is combining together, here new structure will be generated. The sp2 structure is trigonal planar structure. The sp2 structure is trigonal planar structure, it will be takes place. Here the central atom is boron. This is central atom boron. These are the three orbitals are combined here. These are the three orbitals. When these are we are combining here, it looks like spherical shape, that s orbital and p orbital is merged. And coming to that, how many unpaired electrons are there? 3. Here one unpaired electron, here second unpaired electron, this one is third unpaired. Hybridization is what type of hybridization? It belongs to sp2 hybridization. It belongs to sp2 hybridization. Now fluorine, where the electron is present? The electron is present, the fluorine unpaired electron is present in the p orbital. P orbital structure is what type of structure here? Dumbbell structure. The p orbital structure is dumbbell. This one is fluorine atom. Here one electron is present in the p orbital. How many unpaired electrons are there here? 3 unpaired electrons are there. So, how many fluorines we have to take here? 3 fluorines. The 3 fluorine atoms are pointed at the 3 corners of central atom of boron. Fluorine electron, and these are, one is boron electron, fluorine, these all are fluorine atoms. This overlapping is sp2p overlapping. This overlapping is sp2p overlapping. The central atom is boron. Now, if you write in the bond structure, here boron, here fluorine, also fluorine, and this one is fluorine. What type of structure? It's a trigonal planar structure, it will be takes place. In this boron trifluoride, the bond angle is 120 degrees, bond angle it will be takes place. The bond angle is 120 degrees, and boron trifluoride is what type of structure? Is a trigonal planar structure is there, and overlappings are what type of overlappings means? That is sp2p overlappings it will be takes place. The next hybridization is coming to sp hybridization. Sp hybridization means valence shell one s orbital, and here valence shell one p orbital. Valence shell one s orbital and one p orbital, that is sp hybrid molecule. How many number of sigma bonds are formed here? 2 sigma bonds, and these 2 are empty orbitals. That empty orbital, if electron is present, it forms the pi bond. Here, if you see that sp hybridized molecule, example beryllium chloride, BeCl2 molecule. According to the principle, if you are calculating beryllium atomic number 4, beryllium group is second group, that is 1 into 2, and the chlorine belongs to 7th group of element, 2 into 7, 2 into 7, 14 plus 2, 16, 8 2s are 16, that belongs to sp hybridization. Now, beryllium atomic number 4, electron configuration 1s2, 2s2. Here this s orbital, 2 electrons are there. And coming to, if you are writing here chlorine, atomic number 17, helium, neon, 3s2, 3p5. Here 3s2, this one is 3p5, 1, 2, 3, 4, 5. Here how many unpaired electrons are there? The total unpaired electrons are 7, electrons are 7 electrons are there. In that 7 electrons, 3 pairs are present and 1 unpaired. These are the 7 electrons. In that 3 pairs and 1 unpaired electron. Here this one is 2s2, that is outermost electron configuration. Coming to that 2s2, here then orbital is 2p orbital. Now in the 2p orbital is empty condition. Now the 2p orbital is in empty condition. This belongs to ground state electron configuration. This belongs to ground state electron configuration. By adding some amount of energy, this s orbital electron into the p orbital, by adding some amount of energy, s orbital electron enters the p orbital. Here one electron is present in the valence shell p orbital, here also. This is called excited state electron configuration. Here one s orbital, one p orbital, that is sp hybrid molecule. Now sp hybrid molecule structure is linear structure. Here this one is central atom is beryllium. Here one unpaired electron, here also one unpaired, central atom is beryllium. Here sp hybridized molecule, here also sp hybridized molecule. And chlorine, that chlorine unpaired electron present in the p orbital. The p orbital structure is dumbbell structure, that is here one chlorine atom plus this terminal is also one chlorine atom. How many chlorines we are taking here? 2 chlorines. Here also one chlorine. These 2 electrons are combined one bond, these 2 electrons are combined one. This is the orbital representation. Here beryllium atom. Here one chlorine is bonded. Here also one chlorine is bonded. This is beryllium electron, chlorine. Here this one is beryllium electron, chlorine. The overlappings are sp, p overlapping. Here this overlapping is sp, p overlapping. And if you write the structure in the bond formation, beryllium, here chlorine, beryllium and chlorine. Chlorine valence shell, 3 pairs are present. Here also valence shell, 3 pairs, and these are the bond pairs. The electrons which are participating in the bonding is bond pairs. This bond angle is 180 degrees bond angle. Now coming to that, in sp hybridization, valence shell 1 s orbital, 1 p orbital, the overlappings are spp overlapping. It is a linear structure, it will be takes place. The linear structure bond angle is 180 degrees, it will be takes place. When sp3 hybridization, when all bonds are participated, the structure is tetrahedral structure, the bond angle is 109 degrees 28 minutes. When sp2 hybridization is present, the bond angle is 120 degrees. sp hybridization is present, the structure is linear structure and the bond angle is 180 degrees. So these are the orbital representation and orbital formations of sp, sp2 and sp3 hybridations of different molecules. And the remaining topic that will be discussed in the next class. Thank you all of you for what about the